Good morning, students. In this online mode of learning, welcome to my third video lecture on the paper Object-Oriented Concepts and Programming with C++. In my earlier two videos, in the first video, I covered about the different programming languages, their merits and demerits. In the second video lecture, I discussed about an improved concept called structured programming. Why structured programming was useful for programming? What are the benefits of structured programming? Those things I have discussed in my second lecture. So in the third lecture, I'll give you a brief introduction to object-oriented programming. Our entire semester discussion is based on object-oriented concept, how object-oriented concepts can be implemented using program, what are the different features available, etc. Those things will be covered in the subsequent sessions. But this is an introductory lecture. In this lecture or in this video, I will discuss about what is the need for object-oriented programming, what is the basic definition of object-oriented programming. As a recap, in the earlier lecture, we have studied, in the first lecture, we studied about discussed about different programming language, that we know that it's a machine level language. Then it's an improved version is assembly level language. In the machine level language, it has some drawbacks like it is machine dependent and it's a tedious task to remember zeros and one codes. To avoid those two drawbacks, they modified it and come out with another language called assembly level language. Here the programmer is no need to remember the binary code. The programmer can write the program using simple mnemonics like add, sub, else, etc. So when compared to machine level language, assembly language is easier to write. So assembly level language is an improvement over machine level language. But assembly level language also has its own drawback. In an assembly level language, again you have to remember the mnemonic. Instead of binary, remembering the binary code, here you have to remember the mnemonic codes. And assembly level language is also machine dependent. So the mnemonic code will not be common across all machines. So mnemonic code is also varies from machine to machine. But another drawback of assembly level language is computer cannot understand. The program written in assembly level language should be converted into binary code or the machine code using assembler. Again, to avoid this drawback, they come out with another language called high level language. In a high level language, the main advantage is writing program is simple because you need not remember the binary code and you need not remember the mnemonic code also. You can write it in almost English-like statement, and you are permitted to use mathematical operators like plus, minus, relation operators like greater than, less than. So many operators also you can use it. So writing the program in a high-level language is slightly easy when compared to the other two languages. So each language is an improvement over the other one. The main idea of coming out with a new concept is to eliminate the drawback of the earlier version. But a high-level language is also an optimal solution. That's not the best language. A high-level language also suffers from so many drawbacks. The one thing is the computer cannot understand a high-level language directly. For a human being, writing the program in a high-level language is easy. After writing, in order to make the computer to understand the instruction or the lines in the high-level language, the instruction should be converted into, or the entire program must be converted into machine code or the binary code using translator like compiler, interpreter, etc. The program written either by using assembly level language or high-level language, we call it a source program. The converted program in machine level language, we call it an object program or a target program. A computer can understand only object program, whereas a human being can write source program. But a high-level language suffers from so many drawbacks. When you say high-level language, don't assume C language because C is an improved version that will come that one later. A high-level language means a program is nothing but a set of instructions. The program may consisting of 10 lines, 20 lines, 30 lines, whatever it may be. Every line will do some specific task. It could be giving the input to the computer. It could be doing some calculation, or it could be doing some manipulation from the data. It could be the display of certain result. Whatever it be. Any line, if you take in high-level language, it does some task. So in high-level language, a program can be viewed as collection of instructions. That's all. What is the problem in high-level language? A high-level language suffers from basically three drawbacks. The first one is all the data you are using in your program must belong to only one common program, because you cannot divide the program into smaller pieces. Whatever may be the size, you have to write it as one single unit. If you write it as a one single unit, what happens is all the data belongs to that unit only. So everything belongs to that one means it naturally global only. So all the data that are used in a program belongs to one unit means that becomes global in nature. The problem with the global data is security is not there. That's the biggest drawback of a high level language. The second thing is control was in a program. What happens? Sometimes you need to change the order of execution. After executing 3-4 lines, you have to go to some other lines in the program. Then we may have to go back to the previous line, etc. So we need to move from one point in the program to another point in the program. In order to move from one point in the program to another point in the program, we have to use what is known as go-to statement. But usage of go-to statement is not a good practice, because the program loses its structuring property. The third drawback of a normal high-level language, simple high-level language, is writing, understanding, and maintaining smaller program is okay. But all the problem need not be of small size. As the complexity of the problem increases, the normal high-level language loses its potential. So it fails to produce error-free output. Then what is the alternative? Then they introduce what is known as a structured program. In the second slide, we discuss about structured programming. In a structured programming, the main intention is to eliminate all the drawbacks of conventional simple high-level language. Here's the first drawback of a high-level language is all the data that are used in the program are global in nature. But when you come to structured programming, the first concept is you can divide the program into smaller unit. Each unit, we call it as a function. Every function will perform some specific task, and every function can take some input, process the input according to the requirement, and gives out some output. So every function has a well-defined task, and sometimes one function needs to interact with another function also. So the function performs specific task, not only performs specific task, but has a proper interface with other function also. That means the output of one function can be the input for another function. As a simple example, you consider program to perform matrix operation. The different matrix operations are reading the two matrices, then adding the two matrices, subtracting the two matrices, multiplication of the matrix, transpose of a matrix, finding the determinant, etc. So here the program is performing matrix manipulation. So that program is a larger program. So for that purpose, we have divided the program into 4 to 5 units called function. The first function is to accept the matrix. The second function is to display the matrix. The third function is to perform the addition of two matrices. Another function is to perform subtraction. Then next one is for multiplication. One function you can write it for transpose of a matrix, and one function you can write it to find the determinant of a matrix. And now, since the program size is big, I have decomposed or divided the program into 4 to 5 functions. Every function has a well-defined purpose. The purpose of the first function is to accept the values for the matrix. The purpose of the second function is to display the numbers in matrix format. The purpose of the third function is to accept two matrices as input, perform the computation of addition of successive corresponding element in the two matrices, and get you the sum of two matrices. The fourth function is to accept the same two matrices as input, perform the subtraction of the difference of two matrices. The next function takes two matrices input, find the product of two matrices. The fourth function accept the matrix as input, transpose, interchange rows with columns and columns with rows. The last function takes the input as matrix and gives out the determinant, which is a numeric value. So here we have understood that is a concept of structured programming. So every function in a structured programming has a well-defined purpose, and one function can have an interface with other functions also. So in the second video lecture, we have studied why we need structured programming. The structured programming purpose is to eliminate the drawback of conventional high-level language, where a conventional high-level language fails to adapt to the higher complexity. Normal high-level language is suitable for writing small program, But when it comes to structured programming, we can write a program of sufficiently large size, sufficiently high complex program. But structured programming has some characteristics. The thing is, one thing is, in a structured program, since the program is divided into function, any function can have its own data. The function data which is required for a particular function, we call it as local data. Function, some data which is common for all function, you can declare it as global also. The main drawback of high-level languages, all the data are global in nature. When it comes to structured programming, you can have local data as well as global data. The second drawback of high-level language is the control movement was done through go-to statement. Here, the transfer of control from one point in the program to another point in the program is done through conditional statement like if statement, if else statement, looping statement, etc. So there is no need to use go-to statement. So the second drawback of high-level language, conventional high-level language is eliminated with the introduction of structured programming concept. The third drawback of a high-level language is writing, understanding, and maintaining large problem is very, very difficult. But with the introduction of structured programming to the conventional high-level language, we have eliminated that drawback also. But a structured programming also fails in so many cases. When the program size increases beyond certain limit, if the program size becomes too big, then structured programming also fails to produce error-free result. That means structured programming also has certain drawback. The first drawback of structured programming is, in a structured programming, the main focus is on functions. So here in the structured programming, we are not giving importance for data. We are giving importance mostly for function. So the data can easily move from one function to another function. So the function, that means the data of one function can be easily transferred to the another function through argument passing means, where there is no security for your, there is no complete or 100% security for your data. So that is the first drawback. And whenever you change the structure of your data, whenever you modify the data, then what happens is already written program may not work. In that case, we have to modify all the function which depends on the data. So data modification will not, sometimes what happens is it makes the program inaccessible, which makes the program may not work properly. So in that case, whenever the data is altered, all the function which depends on the data has to be altered. So that is a tedious task. The first one is altering of the data cannot be done easily. That's the biggest drawback. And another drawback is, as I told earlier, so structured programming also has certain pitfalls or drawbacks. So in a structured program, the major drawback is the data. Because here we concentrate more on algorithm part or a function part. So data we never consider as important, but in many situations, data is more important than the function. So data must be given importance, but security for data is not 100% in the case of structured programming. The main objective of this session is to identify the pitfalls of procedure-oriented programming. Then I will bring out why we need object-oriented programming. What is the need for object-oriented programming, and how do you define object-oriented programming? I will give a proper definition for object-oriented programming. So one is to introduce the concept of object-oriented programming, give a proper definition for object-oriented programming, and why we need object-oriented. That is very, very important. Object-oriented, I told you, structured programming also suffers from certain drawbacks. That is the reason object programming concept was introduced. But when you attend this session, at the end of the session, you should be in a position to identify why structured programming is also not a 100% good programming concept. What are the weaknesses in structured programming? If the structured programming does not have any weaknesses, means there is no need for object-oriented programming. So first, you should, at the end of the session, you should be in a position to understand the weaknesses in structured programming, then why we need object-oriented programming, and at the end of this one, you should be in a position to give a proper definition for object-oriented programming. I told you now, a structured programming, some of the characteristics are, here the main focus is on algorithm or function. Program is decomposed into what is known as functions only. And data, this is the biggest drawback. Data easily, freely move from one function to another function. So you cannot prevent the movement of data from one function to another function. Through argument passing, we can pass the data. Every function, sometimes what happens, function transform the data from one form to another form. Suppose I will write a function, to find the, what you call, the factorial of a number. So you give the number n as equal to 5. Then it performs some operation on n equal to 5 and gives the result as 120. And if in the structured programming, what happens is, only if the program size is big, we decompose into smaller pieces. Each of these pieces is further difficult for you to handle. Then don't worry. Again, keep on decomposing, etc. Finally, you reach a state where the size becomes very small. For that one, writing program is very, very easy. Writing function becomes very, very easy. So that is the reason how you can handle the complexity in the case of structured programming. But that if the complexity exceeds beyond that limit, then structured programming will not be of much use to the programmer. So it implies the concept of what is called as a top-down programming approach. It is based on the principle of divide and conquer rule. Divide, keep on dividing. Finally, integrate each of these pieces, then to get a solution for your overall problem. And function communicate with each other through passing of argument. I think passing of argument, call by value, call by reference, all these things you have studied in your first semester and second semester in the programming in C and data structure concept. So this is how the functions and data work in the case of object-oriented programming. In an object-oriented program, we have a program is divided into what is known as object. In the case of structured programming, the program is divided into what is known as function. Here the program is divided into number of objects. You can see what is an object. Any object you take, it contains two parts. First part is called data, and second part is related function for that particular data. Related function which operates on the data. So here easily you can see data direct movement from one object to another object is not permitted. So your program is first decomposed into number of objects. Each of these objects can communicate with each other through their corresponding function. So in the case of here in this example, we have three objects: object A, object B, object C. Within object A also we have some data that is specific to object A, and we have some function which operates on the data of object A. So functions of object A cannot operate on the data of object B. Similarly, functions of object B cannot access the data of object C. So that means your data is protected securely inside a particular object. It is the basic concept of object-oriented programming. So the structure clearly indicates how data and function interact with each other in the case of object-oriented programming. In the case of structured programming, two functions can directly communicate with each other through argument passing. But here, two objects can communicate with only two objects can communicate with each other, but data cannot move from one object to another object. So some of the characteristics or some of the features of an object-oriented programming are the main intention, the need for object-oriented programming is to eliminate the major drawbacks of procedural language or structured programming language. The first drawback is you cannot handle the complexity of beyond certain limit. So whatever may be the complexity, with object-oriented programming, you can write program for any problem of any complexity. Now, the way structured programming fails to achieve our objective is there we are not giving the importance for data. We are concentrating only on what is called as function. But when it comes to object-oriented programming, your concentration not on function, your concentration is mainly on the data. So object-oriented programming consider data as a critical element, and it never allow the data to move freely from one object to another object. So data cannot move freely on its own from one place to another. It is tied inside a particular object. So it ties the data more closely to the function. So only the data can be accessed by the corresponding function of that particular object. So object A has some data and function means only those functions inside object A can access the data present inside the object A. And here the decomposition, the program or the problem is decomposed into what is known as number of entities called object. And then once you identify what is an object, then you can add some data into that one and you can add some function into that one. Then you identify what is the next object. Again, identify what is the data for that object, what is the function for that one, add it. So we are keep on adding the data one by one, etc. So initially identify what is the first object, identify what is the data, what is the function, one object is created. Then identify what is the second object, identify what is the data for that object, what is the function for that object. Then you have two objects. Then keep on adding the objects one by one. When you add all the objects, that becomes the complete object-oriented programming. So these are the two widely used definitions of object-oriented programming. So here, every word is very, very important. Object-oriented programming is a method of implementation. So generally, the purpose of any software development is to identify new technology, new technique, new concept to improve the performance. So it's also one method of implementation here, in which the programs are organized as collection of objects which can cooperate with each other. So one object can communicate with another object. Whereas in the case of structured programming, one function can communicate with each other. And each of these objects represent an instance of some class. So every object must belongs to one particular category. As an example, you consider Manjunath sir. Manjunath sir is an example of what is called as an object. So here, Manjunath sir belongs to a type class called faculty. So Manjunath is an example for object, whereas faculty is an example for class. Similarly, in the last semester, you have studied stacks, queue, etc. So stack is one example of object. It belongs to a category called data structure. So Manjunath is an object. The corresponding class for that object is faculty. Similarly, stack is an example of an object, and it belongs to a particular category or class called data structure. So every object represents an instance of some class, and each of these classes are the members of hierarchy of classes. So here what happens is, Manjunath is an example for object belongs to a class called faculty. So that is derived from another class called computer science faculty. That is derived from another faculty called undergraduate faculty, etc. So every class is a member of some upper class. Another definition of object-oriented programming is object-oriented programming is an approach that provides a way of modularizing the program. In the case of structured programming, the modularity is achieved by dividing the program into functions. Here, the modularity is achieved by dividing the program into what is called as object. And every object by creating partition memory area for both data and function. So you have to identify how much memory is required for data of that particular object, how much memory is required for the functions of that object. Then one object, that keep on adding the object one by one. So in any object-oriented programming, the first basic concept is to identify to which class the particular object belongs. Once the class is identified, you can create an object. Once the object is identified, then you identify what should be the data of that particular object and what should be the function of that particular object. And that keep on adding the object one by one. Here you can note down one difference. In the case of structured programming, given the problem P, the problem is difficult, then you decompose into function. Each of these function is difficult, then keep on decomposing further into smaller function, etc. In the case of object-oriented, it is quite reverse. First, you identify what is the smallest object, what is the next object, what is the next object, etc. Then join the object one by one. When all the objects are joined together, your problem is solved. So here it's quite the reverse process. There you are applying top-down approach. Here we are applying bottom-up approach. So to conclude, in this session, we have studied what are the characteristics or features of structured programming or procedure-oriented programming. Procedure-oriented programming is one. The concept of structured programming is incorporated into conventional high-level language. We identify what are the major drawbacks of procedure-oriented programming. The major drawback of is data easily move from one place to another, means there is no security for your data. Then, since structured programming has certain drawback, then it leads to the need for object-oriented programming. Sorry. So object programming main intention is to eliminate the drawbacks of structured programming. So main purpose here is to write program of any complexity. Structured programming can be able to handle the complexity up to certain limit. When the size exceeds that limit, structured programming fails. And in this session, we identified or we learned the need for object-oriented programming, along with what is the meaning of object-oriented programming and some definition for object-oriented programming. So based on this session, these are some of the probable review questions in your examination. In examination, they can ask the question, explain the features of procedure-oriented programming. What are the merits of and demerits could be in procedure-oriented programming? What do you mean by object-oriented programming? Some of the questions may be asked for 2 marks. Sometimes the first question maybe generally it will come in the examination for 4 marks. To check your level of understanding, I have designed some 4 to 5 multiple choice question. In a POP stands for procedure-oriented programming. The program is decomposed into objects, classes, data, function. You can see the result. The correct answer is D, because in a procedure-oriented program, the program is decomposed into functions. Procedure-oriented programming is based on the concept of top-down approach, bottom-up approach, linear approach, none. What will be the correct answer? A, top-down approach. Identify the wrong statement. In a procedure-oriented program is decomposed into objects in procedure-oriented programming. No, in a procedure-oriented programming, the program is divided into functions. The first question is wrong. POP is based on bottom-up approach. POP is based on top-down approach. POP does not model the real-world problem. Definitely. So here, which is the correct answer? The first 2 are wrong, and the last C answer is correct. So answer the third statement is correct. So the correct answer is both A and B are wrong. The correct answer is D. Object includes data and dash. So I have given in the example in the diagram also, the content of an object are data and functions. So the correct answer here it is C. Critical element in an object-oriented programming is, the critical element in a procedure-oriented programming is function or algorithm. The critical element in an object-oriented programming is, there are 4 options: functions, class, data, and instruction. So the most important component of any object-oriented programming, data. The correct answer is C. So the reason is, in an object, the purpose of inventing object-oriented concept or object-oriented programming is to provide more security for your data, so that you should not allow the data to move freely from one place to another, because data is very, very secure, very, very important. So you must protect it as much as possible. But in a procedure-oriented program, what happens is through argument passing, the data automatically moves from one function to another function. Means the data passed from one function can be easily altered by the second function. So thank you. So with this, I conclude this session. If you have any feedback, you can call me over that number, or you can mail me also. Hope you have enjoyed this session. If you have any feedback, be free to send your comment as well as questions. Thank you.